Alright, welcome back guys. So in this lesson here, we're gonna explore more on the limits concept by looking at the two type limits we have. We have infinite limits and we have limits at infinity. So to get started with these two type limits, let's look at an example. Let's consider this function here. Is a rational function, 1 over x minus 1, and we want to explore the limit at x equal to 1, meaning a, let's look at the left side limit, meaning what happened to the function value as x approaches 1 from the left hand side. And then b, let's look at the limit of the function as x approaches 1 from the right side. So we have left and right side limit, and see what those two things are going to be equal. We're going to look at this through a graph afterwards, well, to confirm my answer. Now suppose we don't know what this graph looks like. All we have is the formula, and the function is 1 over x minus 1. In the previous video we discussed to find these left and right side limit, we're just going to observe what happened to the y values as x get arbitrarily close to the constant c. In this case, it's going to be x equal to 1 here. So to do this, we're going to set up a table. Okay, so we just want to observe what's going on with the y value. Okay, as x get really close to 1 from the left side. So from the left side of 1, meaning going up to 1. So let's look at maybe x equal to 0.9. Okay, so if x equal to 0.9, or y is 1 over 0.9 minus 1, so 1 over negative 0.1. So that's what is 1 divided by negative 0.1? So that's going to be negative 10 then. Okay, so if x is 0.9, then y is negative 10. Now let's look at another x value that is close to 1, maybe 0.99 from the left hand side. So now we're going to have 1 over 0.99 minus 1. That's going to be 1 divided by 0.01. So we're looking at negative 100 for the y value. Okay, so the y value are increasing in the negative direction. Let's look at another x value that closest to 1 on the left side, maybe 0.99. So we're looking at y will be 1 minus 0.99 minus 1, so that's going to be negative 1000. So the y values are increasing in the negative direction, so there's no indication that this number will stop at all. It's going to keep increasing bigger and bigger in the negative direction. So in this case here, we can say that as x get closer to 1 on the left side, the limit or the function value, these function value are increasing in the negative direction to negative infinity. Okay, so that means the y values are approaching negative infinity as x values get closer to 1 from the left side. Okay, so that's what we have here for part A. Now let's observe the limit of the function by approaching 1 from the right side. Okay, so if we want to approach 1 from the right side, let's create a table again. Okay, all right, so if we want to look at x values that are closest to 1 but from the right side direction, perhaps we should look at maybe 1.1 to start out. Okay, so that will give us the first y value is 1 over 1.1 minus 1. So that's 1 divided by 0.1. So that's a positive 10. Similarly, we can get even closer to 1 by doing 1.11. So that's 1 over 1.11 minus 1. So that's 100. And then let's get even more closer to 1 from the right side by increasing the decimal. Let's see here. That would be 1 divided by 1.111 minus 1 is 1 over 0.111. What is that? 1 divided by point 0.111. I think I got this wrong. So what I want to do is, not these numbers. If I want to get closer to 1 from the positive direction on the right side, then the next number actually I choose is going to be 1.01, and here is 1.001. There you go. Now we should be on the right track now. So now we have 1 divided by 1.1 minus 1. So that will give us 1 over 0.01. So that's the 100 as the answer. And here you have 1 over 1.01 minus 1. So that's going to be 1,000, right? So each of these x value are closer to 1. So 1.001 is a lot closer than 1.1. And then the y value seems to be increasing as well, but to the positive direction. So this is going to be a positive infinity. So it doesn't seem to slow down or decrease or approach a certain number, but it's just keep increasing. So it's going to be approaching positive infinity. Okay. So in this case here we have as x approaches 1 from the right side, the limit of the function is positive infinity, meaning the y values are approaching infinity. Okay. So we said the y values or the function value are approaching positive infinity as x get closer to 1 from the right side. Okay, so this is an example of infinite limits, meaning our answer, the limit of the function or the function values are not approaching a finite number, is not approaching the number L. From previous lesson we have, limit as x go to c of f of x equal to L, meaning limit exists, right? So in this case, the answer for this limit is not L, it's not a finite number, but it's an infinite, right? Infinity, positive infinity, or negative infinity. So in this case, we have that scenario that can be described as infinite limits. Okay. All right. So now, let's look at this. Let's look at this through the graph. Okay. So you can use your graphing utility, calculator, or anything to graph this. But the graph of this, let's look at graph this. So let's look at the limits through graph. Okay. All right, so f of x is 1 over x minus 1. So if you remember from your algebra course, this graph would look like this. You have a horizontal shift to the right of 1 unit from the origin. So here's 1, and it's going to be vertical asymptote. Okay, and it's going to be like this on this side, and like this on this side. Okay. All right, so here's 1. All right, so what this saying that the graph just increases to positive infinity, doesn't crosses the asymptote, and decrease to negative infinity, doesn't cross the asymptote. So if we get closer to 1 from the right side, right, then a y value, a function value, is increasing to positive infinity. That's what A is saying there. Okay. Actually that's B. And A is saying that as we get closer to 1 from the left side, x value get really close to 1, right? The y value is decreased to negative infinity. Okay. So this is an example of infinite limits. So now we're gonna look at another example, actually the same example, and explain the limits at infinity. Okay, so we can do this through a graph actually. So using the same graph, let's look at limit as x approaches not a number, but approaches infinity of the function f(x), what would that be? Okay, so what this saying that, suppose we want to let x go to infinity, meaning x go to infinity this direction, x get as large as possible. Okay, what is the behavior of the function? What is the behavior of the graph? What is it doing there? The behavior, the y value is decreasing to closest to 0. Okay, so the answer here is going to be 0. Okay, very similarly, we have the limit as x approaches in the negative direction of f of x. Okay, well, if that's the case, we have x get we let x tend to negative infinity. Okay, that's what this means. We are observing the y value. Okay, as x get to negative infinity, the y value is decreasing to negative infinity. Okay, so there's two things we're observing. We're observing the horizontal axis, let x be certain numbers or approach a certain number. And then our limit is going to be whatever the y value is doing, whatever the graph is doing, relate to that particular x that approaching. So in this case, it's going to be 0 as well, right? So x, the y value here will approach 0, okay, because it's getting closer. Okay, so if that doesn't make sense, let's look at this through a table. Okay, here's x, here's y. Okay, let's pick some number where x approaches infinity. So maybe try 10 for x, 1,000 for x, 10,000 for x, and 100,000 for x. Let's see what the y value is doing. Okay, so if we plug these numbers for x, we get 1 over 10 minus 1. So that's 1/9. 1 over 1,000 minus 1. So that's 1 over 999. And then 1 over 10,000 minus 1. So that's 1 over 9999. As you can see here, the y value is getting closer to 0, right? This number is getting closer to 0. This is really small. So as x get even larger, the y value is decreasing to 0. So that's what this is saying. Okay, same thing with this as well. So that's the other concept. This is limit at infinity. So we can say this is an example of limit at infinity. What that referring to is, what is the function behavior doing when we let the value x tend to infinity, either positive or negative infinity? Okay. All right, so in the next video, I'm going to go over several more examples.